Hello everyone, I am Dr. VRAO. In the last video, that is salt hydrolysis part 1, we had gone through the definition of salt and various types of salts. Now I shall make an attempt to explain the concept of salt hydrolysis. Salt hydrolysis. Okay, from the last video we came to know the definition of salt. So the definition of salt is a substance which does not release either H plus ions or OH minus ions in the first ionization is called salt. And we are going to learn about salt hydrolysis. Then what is the meaning of hydrolysis? What is the meaning of hydrolysis? We came to know the definition of hydrolysis. And what is the meaning of definition of hydrolysis? The definition or meaning of hydrolysis is nothing but adding water. Adding water. That is, salt hydrolysis is nothing but adding water to salt. Adding water to salt. What happens when we add water to salt? This is the salt and we are adding water. What happens? Salt solution is formed. Salt solution is formed. Salt water or salt solution is formed. So where salt is a solute and water is solvent, and salt water is a solution. Okay, so in the salt hydrolysis, water interacts with the salt. Water interacts with salt and which results the formation of salt solution. When solution is formed, when we concerns with solutions, we need to address their concentration. Here we need to address the pH of that solution. We need to address the pOH of that solution. Okay, we need to address the pH or pOH of that solution, because salt consists one cation and one anion. So water interacts with the cation, either cation or anion. Okay, so when we add water, water interacts with either of cation, interacts with either cation or anion, and which results the formation of solution. So when we concern with the solution, we need to express their concentration. We need to discuss their pH. We need to discuss their pOH. When we need to discuss the pH if the solution becomes acidic. We need to discuss the pOH if salt solution if that formed solution is basic. Okay, so salt hydrolysis is nothing but interaction of water with salt. Okay, that means interaction of cation or anion or both of a salt with water is called salt hydrolysis. As a result of that interaction, pH or pOH of that solution, pH or pOH of that solution is affected, because if that water interacts with the cation, that solution becomes acidic or basic. If that water interacts with the anion, that results acidic solution or basic solution. Forget about what is the type of solution that formed when water is interact with salt. Let us see what happens when we add water to salt. Okay, so salt hydrolysis is nothing but adding water, that is interaction of water with salt. As a result of that interaction, pH of the solution is affected. Therefore, salt hydrolysis is a process in which either cation or anion or both of a salt interacts with water to form H plus ions or OH minus ions or both the ions is called salt hydrolysis. Okay, I repeat, salt hydrolysis is the process in which either cation or anion or both ions of the salt interacts with water to form H plus ions or OH minus ions or both the ions is called salt hydrolysis. Okay. So, if water interacts with the cation, so salt, let us take the salt as Ba. Let us consider the salt as I shall represent the salt with Ba. Okay. So, it is the B is a cation and A is a anion of the salt. If water interacts with the cation, if water interacts with the water, that forms, it is a strong acid that results interaction of water with cation results weak base. Interaction of water with cation, it is a strong acid and it is a weak base. So, interaction of water with cation results the formation of a weak base. I repeat, interaction of water with cation results the formation of a weak base. Weak base. Okay. So, the solution, the salt solution, the solution formed when water interacts with the cation, the nature of the solution is acidic. Nature of the solution is acidic because interaction of water with cation results in the formation of weak base. So, weak base does not affect the pH or pOH. Weak base does not affect the pH. Okay. So, nature of the solution becomes acidic. Okay, nature of the solution becomes acidic. Okay. And one more thing is when water interacts with the cation, then it is called cationic hydrolysis. That is called cationic hydrolysis. Then it is called cationic hydrolysis. Cationic hydrolysis is nothing but water interacts with the cation. And besides this, there is anionic hydrolysis. Anionic hydrolysis. Anionic hydrolysis is nothing but anion of the salt interacts with water. We know that anion is a strong base. Okay. And interaction of water with the anion results weak acid, results in weak acid and formation of OH minus ions. So, weak acid does not affect the pH of the solution, but here the formation of OH minus ions takes place. So, solution becomes a solution. Nature of the solution is basic. Nature of the solution is basic. Okay. So, what I want to conclude is that when water interacts with the cation, that results in the formation of weak base and release of H plus ions. So, the solution, nature of the solution is acidic. Nature of the solution is acidic because there is the release of H plus ions. And when water interacts with the anion, that results in the formation of weak acid and release of OH minus ions. Okay, so nature of the solution is basic. Okay, so when we add water to salt, salt solution is formed, and that salt solution is either acidic or basic. If that water interacts with the cation, then the nature of that solution is acidic. If that water interacts with the anion, then the nature of the solution is basic. Okay, so and one more thing is that it should be keep in your mind that the way in which water interacts with salt depends on the nature of the salt. I repeat, the way in which water interacts with salt depends on nature of the salt. We have basing on the nature of the salt, we have 4 types of salts. We have 4 types of salts: salts of strong acid and strong base, salts of weak acid and strong base, salts of strong acid weak base, and salts of weak acid and weak base. Let us see what happens when salt hydrolysis takes place with strong acid and strong base. Okay, let us see one by one. Okay, I want to repeat this statement, that is, the way in which water interacts with salt depends on nature of the salt. The way in which water interacts with salt depends on nature of the salt. We have 4 types of salts. So let us see the salt hydrolysis of 4 types of salts. In this video, we are going to we are going to discuss the salt hydrolysis of salt of strong acid and strong base, and salt hydrolysis of weak acid and strong base. Let us see salt hydrolysis of salt hydrolysis of salt hydrolysis of salt hydrolysis of salt or salt hydrolysis. Hydrolysis of salt. What is that salt? Salt formed by the strong acid and strong base. Salt formed from the combination of strong acid and strong base. Okay, let me give one example for salt formed from the strong acid and strong base. So the salt, the best example for salt formed from the strong acid and strong base is NaCl. NaCl, because NaCl is a salt which is formed from the strong base and strong acid. Okay, so what we are doing now, we are going to add water. Hydrolysis of salt. What is that salt? Strong acid and strong base. So we are adding water to this salt. We are adding water to this salt. That what happens? That results in the formation of sodium chloride solution. So sodium chloride, we are adding water. Salt hydrolysis is nothing but adding water to the salt. So that forms Na plus Cl minus ions. Ionization takes place. So I shall write this as NaCl aqueous. because we are adding water to this salt. So, that is why I write it as NaCl aqueous. So, upon its ionization it forms Na plus ions and Cl minus ions, and this is aqueous solution, and in this aqueous solution water is also there. So, water ionization H plus and OH minus ions. Water ionized as H plus ions and OH minus ions. What happens? So, NaCl, aqueous NaCl dissociates into Na plus and Cl minus ions, and water itself dissociate as H plus and OH minus ions. So, due to this there is a reaction takes place between Cl minus and H plus and Na plus and OH minus ions. So, this results formation of sodium hydroxide and formation of HCl takes place. So, NaOH is a base and HCl is a acid. So, those two are getting neutralized. So, what about the pH of the solution, pH of the resulting solution when we add water to salt? The pH of the solution is remains 7, because when we add water to sodium chloride, that results in the formation of sodium chloride solution. Sodium chloride dissociates as Na plus and Cl minus ions, and those Na plus and Cl minus ions interacts with the H plus ions and OH minus ions of water, that results in the formation of sodium hydroxide and water. Those two are getting neutralized with one another, and the solution pH is remains 7. So, final pH of the solution is does not alter. Already I told you that when we are adding water to salt, the salt solution is formed, and the nature of the salt solution is that may be a acidic or that may be a basic. Okay, but here when we are adding water to salt that is derived from strong acid and strong base, that results in the formation of base and acid. Those two are getting neutralized. So, the final pH of the solution is remains neutral, that is the final pH of the solution is 7. Okay. Now, let us see the hydrolysis of salt of weak acid and strong base. Now, let us see hydrolysis of salt derived from weak acid plus strong base. Now, let us see hydrolysis of salt derived from weak acid and strong base. The best example for salt derived from weak acid and strong base is sodium acetate, CH3COO-Na. Okay. So, this is the salt formed from the derived from the acetic acid and NaOH. Okay. So, we are adding water to sodium acetate. So, that results in the formation of sodium acetate solution. So, sodium acetate solution that can be represented as aqueous. So, which upon dissociation it forms CH3COO minus plus Na plus ions Okay. So, CH3COO-Na aqueous gives rise to CH3COO minus plus Na plus. I told you I shall share with one important thing, one important point with you all is that what happens when we add water to salt derived from weak acid and strong base? what happens? So, when we add water to salt derived from weak acid and strong base, the nature of the solution should be, basic in nature. Nature of the solution is basic in nature. How can I say this? Because that salt is derived from strong base and weak acid. So, the resulting solution is in the nature of basic. Okay. So, it should be keep in our mind that when we consist with salt hydrolysis of salt derived from weak acid and strong base, the resulting solution nature is definitely that should be in basic nature. Okay. You can remember with this salt combination, with this combination. In this combination, whichever is strong, then that is the nature of the resulting solution. Okay. For example, if you take a strong acid, weak base, then what is the nature of the salt solution? That should be acidic in nature, because that combination is strong acid versus weak base. So, the nature of the salt solution should be acidic. But here the salt solution is in basic nature. Okay. So, basic nature. So, sodium acetate dissociated to CH3COO minus plus Na plus. Okay. And CH3COO minus is a strong base. You know that acetic acid is a weak acid, but its conjugate base is strong base. Okay. So, strong base. That is why the resulting solution nature is basic in nature. Okay. You can remember this in this way or in this way. Okay. You can remember the nature of the resulting solution by the salt combination or formed product. Okay. So, acetate ion is a strong base, because acetic acid is a weak acid and its conjugate base is strong base, right. Next, and this acetate ion CH3COO minus, this acetate ion interacts with water. What is this? Anion interacting with water. This is called anionic hydrolysis. This anionic hydrolysis, CH3COOH plus OH minus ions. So, this is hydrolysis. So, we are adding water to anion. This is called anionic hydrolysis. So, anionic hydrolysis constant KH is given by, it is the equilibrium reaction. So, CH3COOH into concentration of OH minus ion by CH3COO minus. No need to write the water molecule concentration. Okay. So, this is the hydrolysis constant. Okay na? Now, we shall take the acid dissociation constant. CH3COOH. It is also a weak acid, CH3COO minus plus H plus. So, this acid dissociation constant is Ka is equal to concentration of acetate ion into concentration of H plus by concentration of acetic acid. Okay, right. I shall erase this. Okay. So, this is acid dissociation constant and this is the hydrolysis constant, and we know that ionic product of water Kw is equal to concentration of H plus ions. It is a product of H plus ions and OH minus ions. I want to take I shall take the ratio of Kw by Ka, ionic product of water to acid dissociation constant. Ionic product of water is concentration of H plus ions into concentration of OH minus ions by acid dissociation constant. Acid dissociation constant is this fraction, and when we divide this when we divide the Ka with when we divide Kw with Ka, this fraction is reverted, that is CH3 COOH by CH3 COO minus plus H plus, and this H plus and this H plus getting cancelled. Okay, and CH3 COOH by CH3 COO minus okay. So, if you observe this ratio, that is concentration of acetic acid and concentration of OH minus by concentration of acetate. So, if you observe with this with your naked eye, this ratio is equal to KH. This ratio is equal to KH. So, we can write this as KH. We can write this as KH. Now, let us consider the concentration of this species. Okay. So, CH3 COO minus, okay, CH3 COO minus plus water that results in the formation of acetic acid plus OH minus ions. Okay. So, initial concentration of the, here water interacts with the anion. So, initial concentration of acetate ion is C, and before the equilibrium is established, the concentration of acetic acid and OH minus ions are 0. After the establishment of equilibrium, some fraction of concentration of salt is decreases from the acetate ion, and the decreased fraction is formed as acetic acid and OH minus ions, where H is degree of hydrolysis. Degree of hydrolysis, already I told you, degree of hydrolysis is nothing but the fraction of a total salt that has undergone hydrolysis. Okay, I repeat, degree of H represents degree of hydrolysis. Degree of hydrolysis is nothing but a fraction of total salt that has undergone hydrolysis. Okay, so when water interacts with the acetate ion, some fraction of concentration and some fraction of acetate ions are undergoes salt hydrolysis. That fraction is decreased from this concentration, and the decreased concentration is formed in the form of formed for the acetic acid and CH, that is OH minus ions concentration. So, we can write this acid hydrolysis, salt hydrolysis constant KH is equal to acetic acid, equilibrium concentration of acetic acid is CH. Here the acetic acid concentration CH, and concentration of OH minus ions is CH. This is CH, and concentration of equilibrium concentration of acetate ion is C minus 1 minus H, because if you take the C as common, and it becomes C into 1 minus H. Okay, and in the next step this becomes CCr getting cancelled, CH square by 1 minus H, CH square by 1 minus H. Okay, CH square by 1 minus H, and okay, so KH is equal to CH square by 1 minus H. Okay, already I told you H is degree of hydrolysis, H is degree of hydrolysis. Degree of hydrolysis is nothing but fraction of total salt that has undergone hydrolysis. Only if that fraction is very small, that is H is less than 1, then we can write 1 minus H as 1, because fraction of hydrolysis is very less, very less than 1. So then KH is equal to CH square, KH is equal to CH square, then H square is equal to KH by C, and in the next step H is equal to root KH by C, root KH by C. From this relation we can understand that with increasing the concentration, degree of hydrolysis decreases, or with decreasing the concentration, degree of hydrolysis increases. So with decreasing the concentration, that is on dilution, degree of hydrolysis increases, because H and C are inversely proportional. So on dilution, degree of hydrolysis increases. Okay, now we shall take the equilibrium concentration of acetic acid, acid dissociation. Acid dissociation, where is acid dissociation? Ka is equal to, so acid dissociation Ka is CH3COO minus, CH3COO minus, its concentration is C into 1 minus H, and H plus, concentration of H plus, we do not know the concentration of H plus, hence in terms of C and H, and concentration of acetic acid CH3COOH, concentration of acetic acid is CH, okay, CH, okay, and in the next step 1 minus H, if H is less than 1, then if H is less than 1, then we can 1 minus H is equal to 1, then that is C by CH into concentration of H plus. So next step CC are cancelled, concentration of H plus is A by H, so Ka is equal to this is, and concentration of H plus is equal to Ka into H. So concentration of H plus is equal to Ka into H. Okay, what we are going to, why all this derivation is needed? Because when we are adding water to salt, that results in the formation of solution. That solution is either acidic or basic, but in this salt combination, that solution is basic. So we should we can calculate the pH of that solution or pOH of that solution. Okay, so if you want to calculate the pH or pOH of the solution, you need to know the concentration of H plus ions. That's why this all this calculation is needed. Okay. And in the next step, concentration of H plus is equal to, concentration of H plus is equal to Ka into H, Ka into H, and we know that H is equal to this much, root Kh by C, and in the next step we can write this as K root Ka square into Kh by C, Kh by C, and in the next step root Ka square into KH is nothing but KW by KA, KW by KA into 1 by C. And in the next step, KA into KW by C. So, concentration of H plus is root of Ka into Kw by C. Okay. So, now we are able to calculate the pH of the solution, pH of the resulting solution. How can we calculate the pH of the resulting solution? I want to erase this. Okay. So, concentration of H plus is equal to Ka into Kw by C whole power 1 by 2. That root can be written as a whole power 1 by 2. Okay. Applying logarithm on both sides, log concentration of H plus is equal to 1 by 2 log Ka plus 1 by 2 log Kw minus 1 by 2 log C. Okay. M plus n, by m by n minus n. Okay. So, for the sake of my convenience, I shall multiply the whole equation with a negative sign, negative, this is negative, positive. So, negative logarithm of H plus is pH and negative logarithm of log Ka, that is pKa by 2, and negative logarithm of log Kw, that is pKw by 2, and this is log C by 2. So, pH of the resulting solution is pKa by 2 minus pKw by 2 plus log C by 2. Okay. So, pKw by 2, that is 7, that is 7. So, pKa by 2 minus 7 plus log C by 2. So, pH is pKa by 2 minus 7 plus log C by 2. Okay, sorry, minus pKw minus log Kw is equal to pKw. This is 7 plus 7. So, pH is equal to 7 plus pKa by 2 plus 1 by 2 log C, logarithmic concentration by 2. So, pH of the solution is this. Okay. From this we can calculate the pOH of the solution, that is pOH is nothing but 14 minus pH, we can get pOH. Okay. So, we can get pOH. Therefore, when we add water to salt derived from weak acid and strong base, the resulting solution nature is basic, because the combination, already I told you, in this combination whichever is strong, that is the nature of the resulting solution. So, when we are adding water to salt, so the resulting salt solution nature is basic nature, whichever is strong, that is the nature of the resulting solution, and basic nature. So, the salt solution basic nature, that resulting solution is basic in nature, but we calculated the pH. What is that pH? pH is equal to 7 plus pKa by 2 plus 1 by 2 log C. So, for basic solutions it is customary to calculate the pOH. We can calculate the pOH. pOH is equal to 14 minus pH, that is 14 minus 7 minus pKa by 2 minus 1 by 2 log C. 14 minus 7, that is 7, 7 minus pKa by 2 minus 1 by 2 log C. So, pOH of the resulting solution is this 7 minus pKa by 2 minus 1 by 2 log C. But pH of the resulting solution, if you want to calculate the pH, then pH is 7 plus pKa by 2 plus log 1 by 2 log C. Okay, this is these two formulas are very important. These two formulas are very important in solving the problems. Now, I shall explain the salt hydrolysis of salt derived from hydrolysis of salt derived from strong acid and weak base. Strong acid and weak base. Okay. So, what happens when we add water to salt derived from strong acid and weak base? The resulting solution nature is acidic in nature. So, what is the salt? Because the strong acid, here is the acid is strong. So, nature of the resulting solution is acidic. Okay. So, let me give one example for strong acid and weak base. Weak base example is strong acid HCl plus weak base NH4OH. Salt is NH4Cl, that is NH4Cl, that is salt is NH4Cl. So, resulting solution nature is acidic nature, because the combination in the combination acid is strong. So, the resulting solution pH is resulting solution nature is acidic in nature. So, pH is less than 7, because acidic nature solutions have pH less than 7, but basic nature solutions pH is greater than 7. Okay. So, this resulting solution is acidic in nature. So, resulting solution nature is acidic. Resulting solution nature is acidic. Okay. And the pH is less than 7, because for acidic nature solutions, acidic in nature solutions are the solutions which are in acidic nature whose pHs are less than 7. Then for this also we can calculate the same, we can perform the same derivation. After performing all the long derivation, we can get the equation pH is equal to, pH is less than 7, pH is less than 7. So, 7 minus pKb by 2 minus 1 by 2 log C, minus 1 by 2 log C. How can I write this equation without deriving all the long derivation, without performing the long derivation? because resulting solution nature is acidic. So, acidic solutions nature, acidic solutions pH is less than 7. So, pH should be less than 7. So, you need to subtract 7 minus pK of the weak base, pKb of the weak base, half of the acid dissociation constant. We need to subtract half of the base dissociation constant and half of the log concentration. Okay. So, 7 minus pKb by 2 minus 1 by 2 log C. Okay. These are two very important formulas. Okay. And we can calculate the POH. Of course, no need to calculate the POH. For example, if they ask POH, then you need to subtract the 14 minus pH. 14 minus pH. That 14 minus pH is 14 minus pH is 7 plus pKb by 2 plus 1 by 2 log C. So, that is 7 plus pKb by 2 plus 1 by 2 log C. So, POH is this. POH is this. Okay. So, you keep this point in your mind. Hydrolysis of salt that results in that resulting solution is basic in nature. So, basic in nature solutions pH whose pH is greater than 7. So, 7 plus pK of weak acid, pK of and half of the acid dissociation constant, pK of the acid and half of the logarithmic concentration. Okay. And if you want to calculate the POH, 7 minus pKa by 2 minus 1 by 2 log C. Now, come to this salt. Hydrolysis of salt, strong acid plus weak base. So, the resulting salt solution is acidic in nature, because in that combination acid is strong. Okay. So, resulting solution nature is acidic. So, acidic solution nature whose pH is less than 7. So, 7 minus base dissociation constant pKa by 2 and half of the logarithmic concentration. That is all. And if you want to calculate the POH, 7 plus pKb by 2 1 by 2 log C. Whereas in this case 7 plus pKa by 2 plus 1 by 2 log C, and if you want to calculate the POH, divide the write this equation with the negative sign, add the negative sign for these two values. Okay. So, I hope you all understand this derivation, and you no need to derive or you no need to perform all these long derivation. You need to remember the equations, these equations. You need to remember these 4 equations. Okay. So, in this video we dealt with the salt hydrolysis of strong acid, strong base. Okay. So, the pH of the solution remains neutral or 7, because hydrolysis of salt derived from strong acid and strong base do not undergo hydrolysis, do not undergo salt hydrolysis, because that when water reacts with that salt, there is formation of acid and base, they are getting neutralized with one another. So, the resulting solution pH remains same, that is neutral 7. Okay. So, when we concerns with hydrolysis of salt, when we are hydrolyzing the salt derived from weak acid and strong base, pH is 7 plus pKa by 2 plus 1 by 2 log C. If you want to calculate the POH, just you to subtract the pH from 14, that is 7 minus pKa by 2 minus 1 by 2 log C. And if you want hydrolysis of salt derived from strong acid and weak base, resulting solution is acidic in nature and pH is less than 7. So, pH is equal to 7 minus pKa by 2 minus 1 by 2 log C, and pOH is 7 plus pKa by 2 plus 1 by 2 log C. I hope you all understood this long derivation, and you no need to perform all this long derivation. You need to remember these two equations. Okay, in the next video I shall come up with salt hydrolysis of salt derived from weak acid and weak base. Thank you.